Hi friends, today let's study the chemical reactions of aldehydes and ketones. So one of the important chemical property of aldehydes and ketones is nucleophilic addition reaction. Addition reaction represents the pi bonds breaks in carbonyl group and it changes to single bond. Because aldehydes and ketones are having C double bond O group, which is carbonyl group. In that C double bond O, one of the pi bond breaks in that and changes to single bond. Let's see the mechanism of nucleophilic addition reaction. In that, you see C double bond O, which is carbonyl group that is present in both aldehydes and ketones. In the first step, a nucleophile will be added so that the double bond breaks. Nucleophile will come perpendicular to the plane. So it attacks to the perpendicular to the carbon atom. As a result, carbon changes to the electron from C double bond O is shifting to oxygen side. So carbon changes to C single bond oxygen, oxygen with a partial negative charge and carbon with a positive charge. To the positively charged carbon, the nucleophile will be added which is perpendicular to the plane. So this is the intermediate. And then it continues with the addition of a proton. Proton is positively charged. It attacks with the oxygen that is negatively charged. So we get carbon, oxygen, hydrogen and carbon with the nucleophile. So the double bond changes to single bond and C changes to C single bond OH. This is the general mechanism of the reaction. If it is aldehyde, one of the valency with the alkyl group, another valency with the hydrogen atom and then C double bond O. The reaction proceeds in the same way like adding nucleophile is getting R, C, H, single bond O negative and here carbon with the nucleophile is the intermediate and the proton is added to the oxygen atom so that it changes to R, C, H, OH and here the carbon with the nucleophile. If it is a ketone, this H is replaced by another alkyl group. That's the only difference. So this is a reaction which can be answered by both aldehydes and ketone. This is how we are writing the general mechanism of nucleophilic addition reaction. Let's see some of the examples in that. Some of the important examples. The first one is addition of hydrogen cyanide. We know that hydrogen cyanide, it has a nucleophile like Cn minus and the proton is this one H plus. So it splits to form H plus and Cn minus. In this reaction you can see C double bond O, the carbonyl group, electrons are shifting to the oxygen atom, it gets a partial negative charge for oxygen atom and carbon gets a positive charge. And in HCN, Cn minus is a nucleophile. So in the first step, Cn minus attacks with the carbon. So we get like this, C, the carbon attacks with the cyanide and oxygen with a negative charge. So double bond changes to single bond. So that is this. And in the second step, proton attacks with the oxygen with the negative charge, proton attacks. So that changes to C, Cn is already there and O changes to OH. It means the carbon, this is the product, the carbon with Cn and OH. There are two functional group, cyanide and hydrogen like alcohol. This product is called a cyanohydride. A carbon with two functional groups such as cyanide and alcoholic group is called a cyanohydride. Let's see an example like if I am taking ethanol, CH3C double bond OH plus HCN. In the first step, only Cn minus ion is adding. So CH3, C, H and one of the carbon valency with cyanide and then oxygen with a negative charge. And in the second step, H plus will be added to the oxygen with a negative charge. So we get CH3, H, here Cn, then oxygen with H, OH. So OH and Cn comes with the same carbon. So the product is called a cyanohydride. So similarly, if it is a ketone, this hydrogen will be replaced by an alkyl group, any alkyl group. Results a ketone. Ketone also will give the same product. So with HCN, we get cyanohydrin as the product. Now with alcohol like ROH, this is alcohol. It splits to form OH minus as the nucleophile and then R plus is the positive part in that. Here also in the same way, if C double bond O is there, first step OH minus attacks. So we get C, the carbon with the OH, because OH is the nucleophile, and double bond changes to single bond because this shift is like this, and then oxygen with a negative charge. This is the first step. In the second step, the positive charge here, it is not H plus, it is R plus, alkyl, that is a carbocation, and that attacks with the oxygen with a negative charge. So we get a carbon with OH and OR. This is how it is produced. This product is called a hemiacetal. Hemiacetal. That is what it is written here. RCHOR and OH. The same carbon with OH and OR. And if alcohol is excess, this reaction will continue again with another molecule of ROH. Then the reaction takes place in this way. From OH, this H gets eliminated with the OH of ROH. So it means water will be eliminating and this R attached with the oxygen. I'll explain here. If ROH is excess, then this OH and this H eliminated as water, so that this R means in the added ROH that are attached with this oxygen. So we get the carbon valency with OR 2 times OR. This type of product, you see here OR. This product is called acetal. So when an alcohol is added to a carbonyl compound, first you will get hemiacetal, but if alcohol is excess, then it changes to acetal. Hemiacetal is the carbon or the compound with the carbon valency is satisfied by OR and OH. But acetal means OR 2 times. OR represents either OCH3 or OC2H5, methoxy, ethoxy, such kind of groups 2 times for acetal. And this alcohol reaction is for aldehyde, I explained. But for ketone, there is a specific reaction. Ketone reacts only with the CH2OH, which is ethylene glycol. No other alcohol. Ketone can react only with ethylene glycol. So I'll show you the reaction. You see, R, C double bond O, R, that is ketone plus. To understand the reaction, I'm writing just opposite way, like OH CH2 CH2 OH. So in this double bond means the carbon double bond oxygen will be like splitting in this way. This way it splits. So to one of the bond, oxygen will go. This oxygen is going to one of the side. The other side, no oxygen. Got it? And from ethylene glycol, this is how the water is eliminating. H2O. H2O is eliminating in this way. So minus water. So after the elimination of H2O, CH2O remains. That attacks with this part. It means I'll write it RCR. After that, that bond splits in this way. One side is oxygen. The side where there is oxygen is attached with CH2. CH2 from ethylene glycol, the CH2. And after that, you write the next CH2. It is connected with an oxygen atom. That oxygen is connected with the carbon atom of ketone. So we are getting a 5-membered ring structure like this. It is called a ketal. This is a specific reaction only for ketone. So this is how acetal and ketal are produced as a result of nucleophilic addition reaction of carbonyl compounds. Next is an important reaction, which is addition of ammonia and its derivatives. Ammonia we know that it is NH3. NH3 is called ammonia. NH3 can be generally written as NH2H because there are 3 hydrogen with the nitrogen atom. We can write as NH2H. So while we write the general formula to understand the reaction, instead of this H, we can write Z. The Z can be any of the substituents. So C double bond O NH. First it will split to form. One hydrogen from here will be leaving as H plus. And the remaining portion is HNZ. You understood? One hydrogen is leaving as H plus and the remaining portion is this much. NHZ. Got it? That is minus. That's a nucleophile. So during the reaction, carbon oxygen bond breaks and that carbon is attached with the nucleophile which is NHZ. And the oxygen gets a negative charge so that that oxygen is attacked with the proton OH. It goes like this. And soon after the production of this intermediate, water will be eliminating in this way. H and this OH. Like water is eliminating. As a result, only NZ remains. It means carbon with the NZ. So that if you are putting a single bond, the valency won't be correct. So that it is connected through a double bond. This is how the reaction. But I'll tell you an easy method to understand the reaction. Instead of writing in intermediate, you can write the reaction quickly like this. See double bond O. If it is NHZ, you write H2N. Always H2N is there, only Z is replaced by different other substituents. You just eliminate this water, H2O, and just join these two things. C double bond NZ. This is how we can write the final product. So it's not compulsory you need to show the mechanism and write the intermediate and all. We can quickly write the intermediate in this way, like the product in this way. If it is ammonia, you just write like this. C double bond O plus, for ammonia you can write H2NH. Then this water is eliminating so that we get carbon double bond NH, which is imine. Got it? So here in this tabular column I have given, instead of Z, which all substituent it can be? It can be hydrogen. If it is hydrogen, we will call it as ammonia. Resulting product is imine. Z can be replaced by R, then it is amine. Then the resulting product is called a substituted imines or Schiff's base. Z can be OH, then it is hydroxylamine, it is oxime. It means I will write you the reactions. I mean the compound H2N. Instead of Z, it is H. That is ammonia. Again, H2N. Instead of Z, it is R. Then it is R and H2, alkylamine. Similarly, H2N. Instead of Z, it is OH. Now it is NH2OH, which is called a hydroxylamine. We get oxime as a product. Similarly, H2N, that OH is replaced by NH2. It means NH2, NH2, which is hydrazine. Hydrazone is a product. And then continues. I'm just writing here itself NH2. After that, that is replaced by NH, a phenyl group, which is phenyl hydrazine. Similarly, here also NH2 after that is completely, that Z is replaced by hydrazine with the NO2 substituent, which is 2,4-dinitrophenylhydrazine. And similarly, the last one is semicarbazide. Semicarbazide is NH2, NHC double bond or NH2. So you must study the structural representation of all these reagents so that the product can be written easily. So that you just learn in this way, NH2 Z is the common form and Z can be replaced by which all substituents. Learn in that way, then you will be able to memorize all these reactions. So I'll show you the reaction with ammonia. With ammonia, C double bond O. If it is aldehyde, R C double bond O H. That is aldehyde. Aldehyde is R C double bond O H. If it is ammonia, NH2H. That is ammonia. Then as I told you, like water is eliminating and we get R C H double bond NH. That is imine. So quickly I will be writing the remaining reaction. R C double bond O H. It can be for an aldehyde or a ketone. If it is amine, again you can write NH2, but this time it is R. So this water is eliminating. We get R C H double bond NR. This is alkyl amine. Now with hydroxylamine, R C H double bond O. Hydroxylamine is NH2OH. This time this water is eliminating and we get RCH double bond NOH, which is oxime. Now hydrazine. In hydrazine again, RCH double bond O. NH2, then one more NH2, that is hydrazine. Then this water eliminates, we get RCH double bond and NH2, which is hydrazone. The names are there in the tabular column. You may go through that. Now phenylhydrazine is RC double RCHO plus NH2 after you write NH, then benzene ring. This is phenylhydrazine. Then water get eliminate and we get RCH double bond and NH, then benzene. This is how we can write phenylhydrazone. So it is so simple, like just replace that Z by different substituents. Substituents already the structures I have given before. Similarly, if it is 2,4-dinitrophenylhydrazine, I'll just make this change here. This is a second position 2 and this is a fourth position which is 2,4. 2,4-dinitro. Similarly, NO2 group comes in two different positions like 2 and 4. That is the only change. And last one is semicarbazide. Semicarbazide is RC double bond OH plus again NH2 after NH. You see how I am writing from this table. This thing I'm just writing. Always it is connected with the NH2. That's it. So NHC double bond O NH2. NHC double bond O NH2. Hmm? And then this water is eliminating and we get RCH double bond N NHC double bond O NH2. This is how we can write it. And when you write semi-carbazide reaction, make sure that this H2 is eliminating from a nitrogen which is away from the carbonyl carbon. Because this carbonyl carbon is directly attached with another NH2. Don't take this hydrogen because it is resonance stabilized. So that part is resonance stabilized, no change. NH2 which is away from carbonyl carbon, carbonyl group. Only from that you remove hydrogen and write the product, and this product is called a semi-carbazone. So I will discuss some of the reactions in connection with this. You see this NH2 NH2 which is phenyl hydrazine and CH3CHO which is an aldehyde. So you remove the water in this way. So you will get CH3CH then double bond and NH2 which is hydrazone. Similarly, C6H5CHO that is benzaldehyde and this is semicarbazide, the last one. This is the carbonyl carbon. NH2 is directly attached. Don't take this hydrogen. NH2 is away. This hydrogen only you take it. And that removes with this oxygen. So we get C6H5CH. After that always put the double bond. Don't forget it. Then N, NH, CO, NH2. We can write the product in this way. Now NaCN. We studied HCN. Same only, NaCN and HCN, same kind of reaction. Instead of H, it is Na. So the carboxylic group has no change. And this CHO group only has to be changed. I'll show the reaction in this way. CHO group can be written as CH double bond O. So that double bond O will split and to that oxygen is a negative charge. To that oxygen this Na plus will be added. Got it? So it means CH with the O Na. And to this carbon which is positively charged, that will be added with the Cn minus, which is added with the Cn. So we get the product in this way. If it is HCN, we can write instead of this ONA as OH. That's only difference. Now there is a ketone, cyclopentanone, NH2OH, hydroxylamine, NH2OH. So that you remove this O and this H2 and just join the structure like this, double bond NOH, oxygen. Similarly, this is 2,4-dinitrophenylhydrazine. This oxygen with this H2 as water. So we get cyclohexane with a double bond and NH, then benzene. The remaining portion you just write As it is, no change. Got it. And now there is an aldehyde, an alkene, and it is this oxygen with this hydrogen, semi-carbazide. So RCH, double bond CH, CH, after that put double bond, then N, sorry, not this hydrogen, it is removed from this hydrogen only because that is the one which is away from carbonyl carbon. So N after NH, right side, from right side to left side, from this side to this side you write. NH, then C double bond O NH2. That is it. And finally, you see a ketone. This oxygen eliminates with this hydrogen because it's alkyl amine. So benzene with the CH3 as it is, and this carbon is attached with double bond N, then CH2, CH3. Got it? And the last question. Predict the product when cyclohexane carbaldehyde. Cyclohexane carbaldehyde is this. CHO is attached with cyclohexane. Reacts with excess ethanol. Ethanol is CH3, CH2, OH. This is alcohol reaction. So during the reaction, we write the CH double bond O this way. So the bond breaks in this way and H plus is leaving and this O minus CH2 CH3. Carbon with a negative charge. So when this C double bond O breaks, oxygen is getting a negative charge. So we get carbon with a positive charge and oxygen with a negative charge. This is how it is forming. So H will go to oxygen and this O CH2 CH3 will go to carbon. So we get carbon with a hydrogen and that attacks with O CH2 CH3 and that oxygen with, I'll write the product once more. You see, this is the carbon and that carbon with the hydrogen and there is an oxygen. That oxygen is attached with the hydrogen atom and the remaining portion by O CH2 CH3 like this. And if it is excess ethanol, what is the product, this hydrogen also will replace by that ethyl function, ethyl substituent. CH, O, then one more C2H5. Here again O, C2H5. 2 ethoxy group will come. So more questions you have to practice. So these are some of the important topics which comes under the chemical properties of aldehydes and ketones. Thank you all.